here is part 4 of the 310 final exam review. We're in chapter 16. We're on page 3 of the handout. Find the function values for f of x equals 2x squared minus 3x. When they say f of 0 or f of 4a or f of whatever, the part in the parentheses, goes everywhere you see an x. So f of 0 instead of f of x is 2 times 0 squared minus 3 times 0, and that's going to be 0. F of negative 1 is 2 times negative 1 squared minus 3 times negative 1. Negative 1 squared is 1. 2 times 1 is 2. 3 times negative 1 is negative 3. When you subtract it, it becomes positive 3. Okay, f of 2 is 2 times 2 squared minus 3 times 2, which is 8. Minus 6 is 2. F of 10, 2 times 10 squared minus 3 times 10 is 2 times 100 minus 30, which is 200 minus 30, and that's 170. And then f of negative 5, be careful with these negative numbers, because the signs will mess you up. 50 plus 15 equals 65. Okay, let's look at when there is a variable. So we have f of 4a is 2. Everywhere we see an x, we're going to put a 4a squared minus 3 4a. Whoops. So that's going to be 2 times 4 squared times a squared, distributing that exponent, minus 12a. And that's going to be 2 times 16a squared minus 12a, and that's going to be 32a squared minus 12a. In this problem, we're graphing f of x, the function, equals 1/2 x minus 1. We can rewrite that as y equals 1/2 x minus 1, and that's already in y equals mx plus b format. So m, which is slope, equals 1/2, and b, which is where it crosses the y-axis, is negative 1. So if they ask you what the y-intercept is, it would be when x equals 0, y equals negative 1. So we go to y equals negative 1, take that b and put it right on the graph, and then we use the slope to count. We're going to do something like that, to count up 1 and over 2. So this is the y-axis, the x-axis. There's our points, and terrible line, but anyway, you would draw a line nice neatly on the computer through it, and that is the graph of the function. In number 11, we're to graph the function, an absolute value function. G of x is x plus 3, but it's x plus 3 with an absolute value. What you need to remember is to visualize absolute values. Absolute values are distances, and so if you picture a number line, for instance, x plus 3 is either a distance this way, or it's the same distance this way. So what you would say is, let's rewrite this as y equals x plus 3. So we would say either we go positive, y equals x plus 3, or we go negative, y equals negative of all of that. So, remember also that absolute value is never smaller than 0. A distance cannot be less than 0. Okay. So let's go to the graph. Our two cases are y equals x plus 3 or y equals negative of that. and distributing the negative sign, you get y equals x minus 3. So these are the two lines we're going to graph. So y equals x plus 3. The slope is 1. Y equals mx plus b, m is 1. And for y equals x plus 3, it crosses the y-axis when y is 3. So we go up 1 and over 1, and maybe we'll plot a point that way too, and we're going to go ahead and draw a whole line there. And then the other one is y equals negative x minus 3. So instead of running uphill, we're going to go up and to the left one in a negative direction, and we get something like that. Okay, but let me extend this, and I don't think it's crossing where it would if you had an accurate graph. All right, but we said, let's pretend it's crossing up here somewhere. We said that the function y can never be less than 0 because x plus 3 is never less than 0. So all of this goes away because it is where y is less than 0. And so your graph looks like a V, sort of like this for absolute value, where your graph never drops below the x-axis. In this problem, you are given a graph of a function. The green line is the function. And you're asked, first of all, what is the function when x equals 1? F of x when x equals 1. So the green line is the f of x, and here is where x equals 1. So you go up here and you look at that point and carry it over to the y-axis, and f of x or y equals 1. So f of 1 is 1. Let's look at f of 3. Go up, y would equal 2. But they don't ask us that, but just so you see. Okay, the domain is wherever x wanders. So as you can see, this line goes off to infinity to the left and off to infinity to the right. So x can be anywhere between negative infinity and infinity. All right, let's look for all values of x, such as the function f of x is 2. Well, remember, the function is the graph line, right? And when the function is 2, right here, right there, f of x is 3, or x is 3. When f of x is 2, which is the graph, and that measures on the y-axis, then x equals 3. And then the range is where y goes. It's kind of hard to see. You might want to say, y may not go higher than 3, but actually if this goes off into infinity, it will go higher than 3. So the range also wanders from negative infinity to infinity. Here's a graph of another function, and they want you to find f of negative 1, f of 0, and f of 1. All right, the way this works is they want you to find what is the function f of x when x is negative 1. So let's look at x is negative 1. It's here. The red is the f of x, and so if you come down here at x equals negative 1, f of x, or y, is equal to negative 8. How about when x is 0? When x is 0, f of x, or y, is also 0. And then when x is 1, it drops down again, and f of x, or y, is negative 2. Number 14, use the intercepts to graph x plus 3y equals 6. You could graph this line without using intercepts, but if you do, you'll get the problem wrong unless you just coincidentally use them. So what are intercepts? Intercepts are the places that the line crosses the x and y axis. Now notice, for a problem like this, you're going to have to choose point. So in other words, choose out of the blue some number for y. We want y, we want to know what x is and y is 0, so it's not just some number. We're going to put, when y is 0, x plus 3 times 0 is 6, so x would be 6. Then we're going to, that tells us the, when y is 0, x is 6, so we plot that point. Where is it when x is 0, 0 plus 3y equals 6, so 3y equals 6, divide both sides by 2, and y equals 2. So when x is 0, y is 2. Those are the intercepts, and now you can draw the line through those intercepts. In number 15, you're given 2 points and you're asked to find the equation of a line. The equation of a line has an x and a y in it, and it tells you where it crosses the y-axis and what the slope is. So what we need to know are those two things. You need to know the slope and where it crosses the y-axis. The slope, you can use the slope formula. A nice way to do this is line up your points. There's one point and there's another. These are the x's and these are the y's, so you're going to subtract them. 6 minus 4 is 2, and 5 minus 1 is 4. So there is your x value and your y value. We don't need parentheses around it. And so remember, it's the difference in y's over the difference in x. So m is 6 minus 4 is 2, 5 minus 1 is 4, and you must reduce it. So m is 1/2. Okay, so now we know that y equals 1/2 x, but we need to find b. And you can do this a couple of ways. One way is you can take one of these points they give you and plug it into this equation for x would be 1, y would be 4, and then solve for b. The other way is the point slope formula, which says y minus 1y value equals your slope times parentheses x minus the corresponding x value. So let's use the point 1, 4. You could also use 5, 6, and you get the same thing. Y minus, and then the y value is 4. We know that the slope is 1/2, and the x value is 1. Now we go about just simplifying this. Okay, so I'm going to erase this point so that we have more room to work. Actually, I'm just going to move it up. Okay, so y minus, well, let's add 4 to both sides. So y equals 1/2 x minus 1/2 plus, and I'm going to put it in the form of 4 over 1. 4 is the same thing as 4 over 1. I need to make it have a denominator of 2, so I'm going to multiply that 4 over 1 by 2 over 2. And that gives me, multiplying numerators and multiplying denominators, 8 over 2. And now I can combine my 1/2, so I'm going to say plus negative 1/2 plus 8/2, and this becomes negative 1 plus 8 over 2, because when your denominators are the same and you're adding and subtracting, you just combine the numerators and leave the denominators the same. So we end up with the equation y equals 1/2 x plus 7/2.